All right. I will go in detail through the setup of this one. Again, I'm expecting that you tried it yourself. I'm going to go in detail through the setup of this one. I'm not going to go in detail through the solving of this one. So if nothing else, make sure you write down what answer you should get, and then make sure you solve it to get there. Okay? Outer times whole equals outer times whole. So my outer on this segment, my outer here is 10. My outer piece. Times the whole thing is not x minus 3. That's not the whole thing. The whole thing is this entire segment put together. So that is, I have a 10 here and an x minus 3 here. X minus 3 here, and we're going to add them together, combine them together. So 10 plus x minus 3. That's on the left side. And then on the right side, for my blue segment, I'm going to do the same thing. My outer is 8, and my whole thing is not x plus 3. That's not the whole thing. The whole thing is that I take the 8 on the outside and add the x plus 3 that's on the inside. And that is my entire segment. Questions on the setup before I show the solving? So remember, for the whole thing, you want to take the outside and the inside and combine them together, add them together. All right, here comes the solving. I'm going to outline it, and then I'm going to move on. So here we go. I'm going to simplify the thing that's in the parentheses so that when I distribute it, it's easier. You don't have to do that, but that's just the way I do it, so I only have 2 things that I'm distributing on each side. So I have the 10 here minus 3 here is 7. I have the 8 here plus 3 here is 11. Distribute out. Get everything with x on the same side. Subtract, divide, and I get 9 as my answer for x. So again, at the very least, write down that you should get 9, and then make sure later you can solve it out and get 9. So that is my setup on this one. Outer times whole. Okay? And we're moving on. This is what I'm showing you next is setting up the next theorem, the next idea here. Okay, so you do not need to write this part down. Just watch. You do not need to write this part down. Just watch up here. Outer times whole, because there's a couple problems like this on the homework. So we're going to walk through how these work with a couple of setups. Outer times whole. For the red piece, the outer is x, that's the outside, times my whole thing is not 10, that's not the whole thing. I need to put these pieces together. I have an x here and a 10 here. I'm going to add them together. That's my outer times whole on the red. Pretty straightforward from what we did yesterday. The interesting thing happens over here in the blue. So there are a couple problems on this front page of the homework that were like this. Watch closely. My outer, over in the blue, my outer piece, the piece that's outside the circle, is x plus 4. That's the piece that's outside the circle. Okay, we can see that from the diagram. Then I want the whole segment. What is the whole segment? It's still x plus 4. The whole segment this time is outside the circle, not like here where some of it was inside and we had to add it in. It's still x plus 4. So we're going to write x plus 4 again, because not only is it the outer piece, but it's also the whole segment. So when I do outer times whole, in this case, the outer and the whole are the same. And so multiplying by the same thing twice is the same as squaring it. And so that's why this has written down this squared. So this is kind of the third box on that third page. So again, this isn't really a change from what we had been doing. It's still outer times whole and outer times whole. It's just that my outer and my whole are the same. My outer and my whole match. So we're going to look at a couple more setups that look like this. So again, this says e to a squared. That's because in my blue segment here, e to a is the outer piece, and e to a is also the whole segment. So when I do outer times whole, I'm going to wind up with e to a times e to a, which is e to a squared. All right, so we'll go through a couple more examples here where, again, I'm going to mainly be focusing on the setup. I'm hoping that we can solve some equations where we have to distribute and get everything with x on the same side. So we won't focus on that. We're just focusing on the setup because that's the geometry part of it. Okay, here we go. All right, this one I'm going to just set up. I'm not going to solve it because it's more complicated. In fact, before I forget, I posted this on Canvas yesterday. I ran into this helping some people with the homework. There are 2 questions on the homework that are, like this one, are more complicated to solve than we are used to. And so I'm going to have you skip them. And that is going to be number 5 and number 10 on the homework. So on that worksheet I gave out yesterday, number 5 and number 10, you can go ahead and skip. Okay, I'll say that again when I give homework time, but just so you know. All right, let's talk about setting this one up. Again, we're not going to solve it because that's more complicated than we do here. All right, there's red, there's blue. And we are still doing outer times whole and outer times whole. So again, this treats, your notes are going to treat this as a new theorem, but I'm not going to because it's still outer times whole. Because if I look at my red segment, the A to B, my outer piece, my piece that is outside of the segment, is 30. Times my whole thing, the entire segment, all the way from A to B, still 30. So that's why it writes it as, sometimes you'll see it written as squared. You'll see it written as like 30 squared, because that's what 30 times 30 is. Then over on the right side, I'm still taking outer times whole. My outer piece that's outside the circle on my blue segment, is just x. Times my whole. So my whole segment is all the way across. So I have an x here and a 24 here. I'm going to combine them together. Again, not going to solve because that's more complicated than we've been doing. But that is how you would set it up. Again, in my red, the outer and the whole were the same. So any questions on how that got set up? All right. That's how it would solve. We'll move on. Okay. We're going to walk through this one. I'm going to give you a step and then give you 30 seconds, and then give you another step, give you 30 seconds. Okay, the first hint I'm going to give you is that this x right here is this radius. Okay, you can tell because it's put here and not here right in the middle. Okay, so that radius is x. So guess what this radius here is going to be? It's still going to be the same as this radius because any radius is the same distance. So this is also x. So when you talk about the whole segment over here in blue, the whole segment, I have a 12 here and an x here and then another x here that I'm going to put all together. And then I have this. So again, this is where I give you 30 seconds. See what you can set up with your outer times whole and your outer times whole. Then we'll check that equation and I'll give you a few seconds to solve. And then I'll show the solving. Outer and the whole are the same here. The outer part is 24. The whole thing is also 24. Over on the right side, my outer is 12. The whole thing, remember I have x here, so I have 12 and x will make the entire thing. So before I start to distribute, I'm going to go ahead and combine 12 and x together so that it's easier to distribute. Okay, I'll pause here for another little bit and let you try and solve that now. Distribute. Then we subtract the 144, divide by the 24, and we get 18 for x. And it asked for E to C, so we have 12 on the outside, we have 18 as a radius, and we have 18 as another radius for a total of 48. That's what you're seeing over on the right side. All right. Questions on that? So those are your outer times whole problems. All right. We have one more thing and one more example to write down in the notes. It's fairly easy. And then I'm going to do a homework problem. Okay, so here we go. This is the last box in your notes. It's the last box in your notes to write down. Tangent segments from a common external point are congruent. So when we have this diagram where I have everything coming outside the circle, so I don't have a whole thing that's crossing through inside, I have both of them being tangents. I have a tangent here crossing along outside. I have a tangent here crossing along outside. Coming from the same point, common external point, they're going to be congruent. In other words, in my equations, I'm going to set them equal to each other. And that includes, sometimes you'll see the diagram draw the radius so that they show the tangents. So you might see a problem look like this, where it shows these and then it has like this measurement is 5. Ignore that. Just focus on these tangents, which you're going to set equal to each other. So when you see that on the homework, focus in on the two tangents here, and you're going to be setting them equal to each other. All right, so let me do an example with this so that you see it. So this is one more thing to write down in your notes. You're going to have to write down the problem yourself on kind of down at the bottom. This one. So you're going to draw a circle. You're going to draw two tangents coming onto here. The top one's 28. The bottom one is 3x plus 4. And because these are both tangent segments, in other words, there is nothing going through the inside of the circle, so we don't need to worry about an outer times whole kind of situation. Because these are both outside the circle here, they're going to be congruent. So when we set up our equation, we can just set them equal to each other. We can just say that 3x plus 4 equals 28. That's our equation. So if they're both all outside the circle, we can make them equal to each other. So then subtract and divide. And we get x to be 8. All right. That's the last problem you need to write down in your notes. But there is a problem on the homework that I want to do together with you. So make sure you have out the worksheet from yesterday. If you haven't gotten that out already, make sure you get it out. And I want you to look at the last problem. The very last problem is the one that we're going to do. So on the back, you'll see some of the part times part questions again. You'll see some of these where you're just going to set the two tangents equal to each other. And then I want you to jump down to the end and this last problem here. And it asks for you to find the perimeter of the polygon. So this is number 17. And what we're going to be doing here is we are going to be using the fact that these common tangents have to match. And so we're going to find where they are and kind of use that to build our way around the circle and get all the measurements. It's going to work nicely that we're going to kind of work our way around the circle. So, first one. The first tangent comes from here and connects to this point on the circle and this point on the circle. So those are the first set of common tangents. And those two common tangents have to be the same. So if this is 6.9, this is also 6.9. Remember, we're trying to find perimeter, and perimeter means add up all the sides. Okay, so we decided since this was 6.9, this was also 6.9. The next one, working my way around, the next point out here is this one. So I connect the tangent to here and the tangent to here, and those two have to match. Since this is 12, this is also 12. Next one. Here's the point out here outside the circle. And so these two pieces have to match. Well, I don't know what either of them are, but I can get this one down here because this whole thing is 18.2 and this part is 12. That leaves the rest of it in green. The rest of it needs to be 6.2 by subtracting. Oh, and those two in green have to match. So since this is 6.2, this is also 6.2. And finally, the last pair that has to match is these two. So this is 17. This part is 6.2. That leaves this part to be 10.8, which means this is also 10.8. They have to match. Again, because they are common tangents that go to the same point. So it's using this same idea, just in a much more complicated looking diagram. So now let's get into the pieces of finding the perimeter. And that's by adding up all the sides. Let's see. We have this side being 17. We have this side being 18.2. This side here, if I add these together, I get 17.7. And this side here, if I add these together, I get 18.9. So my perimeter, adding up all the sides, we have 17.7 and 18.9 and 18.2 and 17. Add those together and we get our entire perimeter. So that is number 17. 16 is easier because you're only dealing with 3 sides, but it's the exact same idea. You're going to pick out your matching tangents and work your way around your circle.